My name is Dr. Jonathan Barron, and I'm here to talk to you today about my research in nuclear physics. I study the nucleus, or the core of the atom, which is composed of protons and neutrons. Around that, electrons orbit in a pattern sort of like the planets surrounding the sun, but I'm interested in the protons and neutrons. If you've studied chemistry before in high school, you might be familiar with electrons and the shells that they form around the atom. In a similar vein, protons and neutrons also form shells. What I'm interested in is how energy will change the shape of these shells. I'm going to talk about holmium-157, which was a part of my research. But first, I want to talk about what's the application of this research. A lot of people ask me that. And my answer is typically, I don't know yet. What I do is called basic research. I'm searching for answers to questions that haven't been made yet. A lot of technology that we take for granted actually comes from basic research. Did you know that 90% of Americans have a microwave oven? We've got James Maxwell to thank for that. Now, when he was creating in 1865 his equations governing electric and magnetic fields, he didn't know that I was going to use that this morning to make a quesadilla in 60 seconds, but here we are. Now, the work that he did would later be compounded upon by work done like others, such as Hertz, Marconi, and Tesla. Kuhnhold used this research to make the first radar in 1933. In 1945, Percy Spencer was a technician working on a military radar, and he discovered that the candy bar that he had in his pocket was melting. After some work, this led to the creation of the first microwave oven. This would not have been possible without the contributions by Marconi and, of course, Maxwell. A friend of mine put it best: you got to know how to make the wheat before you can make the bread. Now, in this story, I'm a humble guy. I'm not James Maxwell, I'm not Percy Spencer, I'm not Kuhnhold, but I might be Marconi. I might be the guy who discovers the thing that leads to the thing that becomes something that we use every day. But I can't tell the future. I don't know what's going to become of my research. If I had to make a guess, I would say battery technology, but it just as easily could be warp drive or something. What I do know is that when I'm in my laboratory, I'm Sherlock Holmes. Let me back up for a moment. We need to get back to holmium. Now, we want to create a weird version of holmium, one that doesn't exist in the wild, so that we can see even more weird shapes. The way we did this is we got a nuclear accelerator in order to take a ball of tin and a beam of chlorine and smash them against each other to create holmium. In order to have that happen, you've got to get something going really fast, which is why we used a nuclear accelerator. But we were like, well, we can get it going even faster, and that would put more energy into the resultant holmium. So now's where the detective work comes in. We don't actually have that end result holmium. It died, it broke up. But we know what happened to it while it was dying. It spit off neutrons, and then it spit off gamma rays. And the gamma rays is where I'm interested in. Gamma sphere was a device used in the 2003 Hulk movie, which isn't even canon, but it was based on a real device called gamma sphere, which is the largest gamma ray detection array in the United States. It consists of 108 individual detectors, all in a ball shape around our target. So that means that when the nucleus breaks up and shoots off these gamma rays, gamma sphere is there to catch it. Now, it turns these gamma rays into a little database. This is where Sherlock Holmes comes in. This is where my forensic work comes in. An atom has died and left behind a blood splatter of gamma rays. It left behind fingerprints. That's what this database has as evidence. We look at the energy structure and the relative propensity of these gamma rays in order to get a sense for what was happening. Now, if we've got a regular pattern, that's fine and all, that's still helpful, but sometimes we get weird patterns, changes in energy that we don't expect, and that can only be described by the nucleus changing in shape. We then compare to other nuclei that have been studied, so that we can get a sense of the big picture. Now, the end result of all this, it might not impress you too much. What I found was that holmium-157 is very similar to erbium-158. Not the same, but still has similarities. The only difference between these two atoms is one proton. So that must mean that the fact that they both have 90 neutrons is what's actually important for this strange behavior. Now, I don't want you to take that as your takeaway from this talk. What I want you to remember is that basic research leads to things that we don't expect. I don't do it because I know that I'm going to make a battery or a microwave oven. I do it because I work with cool devices. I've got cool programs. I do detective work. Maybe someday there will be a microwave oven because of me. Probably not.